Hi guys. All right, so now we're going to get into atomic structure and then eventually into the periodic table. So we already learned in previous chapters that the atom is the smallest particle of an element that has all the properties of that element. Well, what's inside that atom? You've probably already heard of these terms, but there are three subatomic particles, and they are electron, proton, and neutron. Okay? How do they compare? Well, an electron has a negative charge, -1. A proton has a positive charge, +1. And a neutron has no charge, 0 charge. Okay. I wrote down the masses in grams for each one of these. Obviously, you don't have to memorize these, but I just wanted to write the masses so you can see relatively how they compare. An electron has a mass of 9.109 times 10 to the minus 28 grams. Very, 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 very tiny. Very, very, very light. A proton is considerably bigger than that, even though it's still a really tiny mass, 1.673 times 10 to the minus 24. And notice a neutron is very similar to a proton, 1.675 times 10 to the minus 24 also. So all very tiny masses, but relatively speaking, protons and neutrons have equal masses, and they are around 2,000 times heavier than an electron. Okay? So, which ones are the heaviest? Protons and neutrons. Which is the lightest mass? Electrons. All right. Where are all these things located? Well, protons and neutrons are located in the middle of an atom in something called a nucleus. What happened to my, here it is, sorry guys. So these guys are found in the nucleus. All right, so the protons and neutrons are found in the nucleus. Well, if the protons have a positive charge and the neutrons have no charge, what would the charge of the nucleus be? It would be positive because you got a bunch of protons there, a bunch of neutrons. Well, these don't have any charge, these are positive, so the nucleus is positive. And sometimes when you're reading in the book, they call them the nucleons. Nucleons are the things that live in the nucleus. What lives in the nucleus? Protons and neutrons. Well, then where are all the electrons? The electrons are moving around the nucleus in the atom in this area that is pretty much empty space. And the electrons are so tiny, but they move around in that empty space. Okay? Let's talk about a new unit. There's a new unit that you guys are going to learn. Now, we learned about units in the last chapter, but there's a new unit of mass that you're going to learn that is now associated with atomic masses. Like if you're talking about a mass of an atom or a mass of a proton or a mass of a neutron, we're going to use a new unit called AMU. This stands for atomic mass unit. Okay? And 1 AMU is equivalent to 1.6606 times 10 to the minus 24 grams. See this minus 24 for proton, minus 24 for neutron? See how these three numbers look very similar? So basically what we're saying is that one proton weighs 1 AMU. One neutron weighs 1 AMU. Well, what does one electron weigh? We don't even talk about the mass of an electron. It's so much lighter than protons and neutrons that there's no point in even mentioning it. It's not that they don't have mass. They obviously have mass, but it's insignificant. Okay, so we talk about the electron's mass as being insignificant. All right, so when we look at an element, we talk about how many protons that element has, how many neutrons it has, and how many electrons it has. And the way we can summarize all that is in something called a Nuclide symbol. So let me show you what a Nuclide symbol looks like. You write that term down, Nuclide symbol. All right. So the Nuclide symbol has the atomic symbol. Now, hopefully you guys have been studying all of the elements that I gave you, and you already know the key elements that you should know for this semester. So they put the atomic symbol here, and I'm just going to represent it as an E. And then the Z number down here, that's called the atomic number. And I'll explain what that is in a minute. And then the A number is in the upper left-hand corner. A number, that is the mass number. All right. So we're going to start using nuclide symbols. I'm going to have the atomic symbol right here, and then I'm going to have a number down here and a number down here. What do these numbers represent? Well, the atomic number represents the number of protons. In fact, it's the atomic number that will determine what the element is, okay? Every element has a completely different atomic number. You will never find two elements that are different elements that have the same atomic number. There will be scenarios where they have the same atomic number, but it would be the same element, but isotopes, and we'll get into that a little later. But right now, every element has a different atomic number. Mass number is basically the mass of the element. Remember how we said that protons and neutrons are the ones that are going to account for the mass of the element? Electrons are insignificant. So in order to figure out the mass number, this is the number of protons plus the number of neutrons. Okay, protons plus neutrons. Okay, so let's put some nuclide symbols here. Let's say I've got this and this and others. Okay, here are three different elements. If you bring out the periodic table, always have it with you. All right, if you bring out the periodic table and you look all the way through here, let me get my glasses because I'll see better with my glasses. Okay, if you look all the way through here, right here, you're going to see carbon. There's carbon, okay? Notice the number on top in the periodic table is a 6. Well, all the numbers on the top, those are the atomic numbers. But in a nuclide symbol, where do we put them? We put them lower left. So if you look at fluorine on the periodic table, what number do you see on the top? It's a 9, lower left. Bromine, what number do you see on the top? 35, lower left, 35. Okay, so these atomic numbers represent the number of protons. So if I asked you, how many protons does carbon have? You would say 6 protons. How many protons does fluorine have? You would say 9 protons. How many protons does bromine have? 35 protons. Okay? Now, what about neutrons? How are we supposed to find out the neutrons? Remember how I said that the mass number is the protons plus the neutrons? So in order to figure out the neutrons, all you have to do is take the mass number minus the number of protons, you'll get the neutrons. Or basically, the mass number minus the atomic number will give you the number of neutrons. Okay? I'm going to erase this so I have some space here. All right, so in order to figure out my neutrons, 12 minus 6 is 6, so I have 6 neutrons. 19 minus 9 is 10, I have 10 neutrons. 80 minus 35 is 45, I have 45 neutrons. Make sense? Okay, so now with a nuclide symbol, you can figure out the number of protons, you can figure out the number of neutrons. How are we supposed to figure out the number of electrons? Well, here's the deal. In a neutral atom, meaning that it has no net charge, in a neutral atom with no net charge, it's not an ion like we're going to get into in the next chapter. It's not positive, it's not negative, it's neutral. In a neutral atom with no net charge, the number of electrons is equal to the number of protons. So basically, the atomic number gives you the number of electrons also. So to finish up this story over here, carbon, since it has 6 protons and it's neutral, it also has 6 electrons. Fluorine, since it has 9 protons and it's neutral, it has 9 electrons. Bromine, same scenario, 35 electrons. Okay, so you should be able to look at any nuclide symbol and tell me number of protons, number of neutrons, number of electrons. Okay, we'll do more in the next video.